Here we have chapter 4.2, dividing polynomials, but day 2. And today we are doing synthetic division. Synthetic division is another type of division other than long division. And synthetic division can only be used when the leading coefficient of the divisor is equal to 1, such as x plus 5 or x minus 2. The leading coefficient on both of those with the x is 1. To set up synthetic division, if you have a quadratic or any polynomial, such as ax squared plus bx plus k, I used k here so not to conflict with the c down here, and we are dividing that by x minus c. So that's the formula to obtain c. So if the divisor is something like x plus 5, then we convert that into x minus a negative 5 so that we know that c is equal to negative 5. The way that we work with synthetic division is we take that C value, we put it out front, and we do this upside down division box. And we are going to write the coefficients of the polynomial inside the box, A, B, and K. We do not put any variables. We will bring this A straight down, and what we do is we take C times A to bring up here, C times A, whatever that value is, and then we add. Okay, the difference here is we're adding instead of subtracting. In long division, we subtracted, but because we're taking x minus c, that's the opposite of that value, so we're adding here. So when you have your c times a, you're going to add that to whatever that b value is to get this number down here. And then you're going to take that c again, multiply it by the whatever number you get down here, and bring it up here to add to the k. And whatever this final number is down here, that is the remainder. So hopefully you kind of understand how this this is all organized. And let's go look at doing an actual problem. I think you're going to like this method a lot easier. It's a lot easier and a lot quicker than long division. So hopefully you'll catch on to this quickly. And we will be using this throughout chapter 4. So in this example, let's take 2x to the third minus 7x squared plus x and divide it by x minus 3. Since the divisor is already a minus, our c value is just the 3 that we see there. The one thing we do have to take care of is the fact that there is a missing term. We're missing an x term here. So we're going to fill in with a 0x. So I have this already set up. The 3 is out in front. We are going to put the 2, negative 7, the 0 for that x term, and then 5. So as I said up above, you're going to bring that first value straight down and write it down here. Now we do 3 times 2. 3 times 2 is 6. Okay, I'm just going to show you my work to get the number here. I add straight down. So negative 7 plus 6 is negative 1. We're going to go back to the 3, down to the negative 1. We're going to multiply those. 3 times negative 1 is negative 3. 0 plus negative 3 is negative 3. We go back to the 3 up here to multiply by the negative 3. And 3 times negative 3 is negative 9. So we're adding 5 plus negative 9. That is negative 4. Remember, this last number right here is the remainder. So now these are coefficients of our quotient, our q of x. And what we need to do is take the initial polynomial that was a degree of 3. Our leading term was an exponent of 3. So our leading term here is going to be 1 less than that 3. So we're going to start with 2x squared. The next number, as long as it's not 0, we're going to decrease our exponents by 1. So we're going to have minus 1x. And then this last number here, if we decrease we already are at 1, so if we decrease, we're at 0 x's. So this last number here is a constant. And then we have a remainder of negative 4. So we can put negative or minus 4 over the divisor of x minus 3. And that is our answer when we divide. So we can write it as 2x minus 3 minus 4 over x minus 3. If we have to write it into the division algorithm, we would write p of x is equal to d of x times q of x plus the r of x. Now, remember, this initial polynomial is p of x. The denominator is our d of x. This part of the answer without the remainder is our q of x. And the remainder, not the fraction, but the remainder is our r of x. So we just write that in. 2x cubed minus 7x squared plus 5 is equal to x minus 3 for our d of x times 2x squared minus x, or 1x minus 3 minus our 4. So we've got our answer just written with the remainder as a fraction, and we have our division algorithm right there. Let's move on to this example here. We have 6x to the fourth plus 10x to the third plus 5x squared plus x plus 1, dividing that by x plus 2/3. Because this is plus, our c is going to be a negative 2/3, and we're going to write negative 2/3 out here, and then all the coefficients in our division box, 6, 10, 5, 1, and 1. Just like we did before, we're going to bring this 6 straight down, and then we're going to multiply negative 2/3 times 6. So negative 2/3 times 6. And I'll go ahead and use your calculator if you need to. And that negative 2/3 times 6 is negative 4. And we're going to be adding. So 10 plus negative 4 is 6 again. We're going to go back to that negative 2/3 to multiply by the number down there, which is another 6. And we already know that is negative 4. 5 plus negative 4 is 1. We're going to go back to the negative 2/3 to multiply by the 1. So negative 2/3 times 1 is negative 2/3. 1 plus negative 2/3 is positive 1/3. We're going to go back to the negative 2/3 to multiply by 1/3. We're going to have negative 2/3 times 1/3 to get our number here. So that is negative 2/9. When we add 1 plus negative 2/9, we get 7/9. And this is our remainder. So if we write that out just as an answer, that is 6 x. We have to decrease our exponent here, the leading term, from 4 down to 3. So 6x to the third. And then we just keep on decreasing by 1. So 6x squared plus 1x plus 1/3, because now we're out of x's. So the 1/3 is a constant. And then that's why the 7/9 is a remainder. And we would write plus 7/9, I guess, over. No, I'm just going to write that as a remainder, r. So remainder 7/9. I'll go ahead and put a semicolon here. So here is our q of x and our r of x. So 6x cubed plus 6x squared plus x plus 1/3 with the remainder of 7/9. All right. Here's another thing to learn about. It's called the remainder theorem. And if we have a polynomial, p of x, that is divided by x minus c, then the remainder could be found by evaluating the polynomial by plugging in the value of c. So if we go down here to this example, we have p of x equals x cubed minus x squared plus x plus 5. Our c value is -1. Now remember that would come from x plus 1 to get a -1 because it would be the opposite of that, just as a side note there. Okay, so to set this up, we're going to, first of all, I'll show you the synthetic division. And to set it up, we get -1 and for our c value out here. And then we fill in the coefficients. We don't have any missing terms, so just 1, -1, 1, and 5. We will bring down the 1. We go to -1 times the 1, so -1 times 1. That's -1. We are adding -1 plus -1 is -2. We're going to go back to that -1 to multiply by that -2, and that gives us a +3. 1 plus 3 is 4. Now we go back to -1 times the 4, which is -4, and 5 plus -4. Oops, I made a mistake. Sorry about that. This is going to be -1 times -2 is +2. I was thinking ahead and I wrote 3. 1 plus 2 is 3. -1 times 3 is -3. And then 5 plus -3 is 2. So our remainder is 2. And that's really all we're looking for. Now if I go over here and do the remainder theorem, I'm plugging in -1. I'm doing p of -1. So I get -1 cubed, which is -1, minus -1 squared. Well, -1 squared is +1, plus a -1, so -1, plus 5. When I add all those together, -1 minus 1 is -2, okay? Minus another 1 is -3, and -3 plus 5 is 2. So I got the same answer for the remainder, doing the long division, or by just plugging in the -1. And that is the end of day 2.